Nikola Tesla firstly developed the wireless power transfer, WPT. But he failed to make the technology effective. The late 20th century, the need for WPT emerged when mobile electronic devices became popular. Nowadays, there are some outcomes which can be applied to a wireless sensor network, WSN. We will introduce three major technologies for WPT and discuss about the application to WSN. Inductive coupling works by magnetic field induction. Due to its simplicity, inductive coupling has been successfully commercialized like electric toothbrush, charging pad for cell phone, but the power transfer falls off steeply and require accurate alignment. EM radiation emits energy from the transmit antenna of a power source to the receive antenna via radiative EM waves. It can be classified into omnidirectional and unidirectional. For omnidirectional radiation, a transmitter broadcasts EM waves and a receiver tunes to the same frequency band to harvest radio power, but the waves decay quickly over distance, and strong waves have potential health hazards. When a clear line of sight, LOS, path exists, it is called unidirectional radiation can achieve which can transmit high power over kilometer range. 1980s, and plane was designed, which can fly in restricted region using this technology, but it is too hard to track for WSN. The next technique is magnetic resonant coupling. Here is its principle. First, a rapidly oscillating electric current is applied to a coil at a specific resonant frequency. This creates a magnetic field in the region around the coil. Tune a second coil to the same resonant frequency as the source. It will couple resonating and converting the oscillating magnetic field into an electrical current within the second coil. This response is called coupled magnetic resonance. By attaching the second coil to devices, such as a mobile phone, this current can be made to do useful work. The source can be either centimeters or meters away from the device being powered. It can deliver power through walls or other obstacles. The preliminary experiment has been done by Kurz et al. In 2007. He powered a 60-watt light bulb from a distance of 2 meters away with about 40% power transfer efficiency. It is significantly different from inductive coupling that was limited to very close range, or EM radiation that was restricted to low power, a few milliwatt energy transfer. Next, we will look at the application of EM radiation in wireless sensor networks. The technology is chosen because the sensor locations are unknown, the receivers can be tiny, and it doesn't require much power. Well, some experiments were conducted. Great solutions were found. The first experiment was done to charge nodes via PowerCast chips, but the efficiency was too low. Then they tried to utilize a mobile reschedule the charging time and amount. However, the overall efficiency were. Some scientists developed a Tran chargers to minimize the number of chargers. They needed 100 chargers over a hectare. Finally, energy harvesters absorb energy from radio signals, so ultra-low power nodes can be supported. Looking through the 4 experiments, see some limitations of omnidirectional EM radiation. Low efficiency, sensitive to obstruction, and not quite safe. Magnetic resonant coupling is the most suitable choice for wireless sensor network compared to electromagnetic radiation, because it offers many benefits such as no requirement of line of sight, higher efficiency and omnidirection and immunity to neighboring environments such as weather conditions. In this diagram, the mobile wireless charging vehicle will occasionally visit each sensor node and charge its battery based on magnetic resonant coupling. To offer unlimited lifetime for wireless sensor network, a concept called renewable energy cycle is introduced, and it needs to be fed with both necessary and sufficient conditions. To optimize the distance traveled, it is the shortest Hamiltonian cycle. For scalability, a new model is proposed to have the ability to charge multiple devices at once within the range of the wireless moving vehicle. In addition, a cellular structure that partitions two-dimensional planes into adjacent hexagonal cells is being proposed as well. To further optimize it, we need to consider traveling path, flow routing, and traveling time. In summary, we briefly talked about the history of wireless power transfer and the 3 technologies that has been in use over the years. On top of that, we have also pointed out the limitations and possible applications. Although omnidirectional electromagnetic radiation may be viable, it is shown that magnetic resonant coupling is clearly the favorites to provide energy needs for the wireless sensor network.